Alright, so for problem 4.1, we'll go through and do this exercise. And I've got it laid out so that I'm going to do node 1, node 2, node 3, 4, and then this will be element 1, element 2 is this one, element 3, and then element 4 when we add that one. But to start out with, we'll do just the first, just the beam, just like the problem indicates. So we'll switch over to that. Push this down so way. See if we can. This create. So for our geometry, we'll do our XY point, which we've been doing, and it appears that unchecking auto execute is a good habit to get into, so we'll start trying to do that. So we'll create point 1, and then we want all our units to be in meters. So this is node 2, and then node 3, and node 4 will be 400. Apply. We're not going to do the 5th node because we have to create our horizontal beam first, do our stress analysis, then we'll add the supporting tube and add that node when we do that. So
can you not do them all together then? I mean, can you not do it all at once right now?
well, I can add the node, but I don't know what it would do to the analysis if I'm not. We need to be able to analyze the beam without the support first.
Okay.
Because as part of the question, it's asking to evaluate the effectiveness of the rod in reducing the stress in the beam.
Okay.
So we need to analyze it without that to begin with. Now, so if we go to label control here on the home tab, and I turn on the points and the curves, it keeps that information up on the screen for me, so it's easier for me to track and remember where I am. And then you can just close that. You don't have to leave it open. So curves, and I want to do point to point. Turn off the auto execute. So we're going to start. Oops, let me put my cursor there. At node 1, go to node 2, and apply since I'm not in auto execute mode.
Did you make your point for 5 meters away or 4 meters?
Should have been 3 meters.
Or sorry, I meant 3 or 4 meters.
It's 3 meters.
Okay, just go to
Well, let's see.
It doesn't look like 3 is right between 1 and 4.
Okay, so let's go to show and points, which distances. So if I do that point to that point, oh, you're right. I did it at 4. Okay, thank you. So let's go back here to, what do I want? Whoops, none of that. Edit. And let's see, I need to edit a point. No. Well, maybe the easiest thing is just to delete it and do it again. Let's see, edit, point list. It's just giving me equivalency. Okay, we'll just delete it. Okay. So use the broom, clear the screen, go back and recreate point 4. There we go. Wow. That looks a little better. So go back to making curves. 1, 2, 3.
Here's the very top.
2, 3, and 5. 3, 4. Okay, so I have my 3 curves connecting my nodes. We go to properties, isotropic, and we're doing steel. So input 30 e to the 6.3. Okay, apply. Now we're doing beam elements instead of rod elements. So select beam, 1D, and say give it a name, and input properties. So here we have to click on this create solution, and it's going to give you this. And you have to enter a name, so let's call it beam. And then these are the different shapes that of beams that you can use, and you can just use the arrow to cycle through them. We're going to select our solid rectangular beam and our width, so 10 millimeters, but our units are going to be Newton meters squared, so we want to put this in as 0.01 meters, and our height as 0.1 meters, and click OK. And we can select our material, steel. And if you scroll down here, you'll notice that it's filled in the area, 0.001. Gives us a shear. There should be somewhere down here a moment of inertia. No, yeah, I went past it. Oh, yeah, right here. 8.33. So, well,
what did you do when you clicked after you clicked the solid beam and entered the width and height?
yes.
You just selected.
Oh, then you. Okay, so let's see. So if I go here, no, that's okay. So if we go here, and I selected the solid beam,
Okay.
and then I put in the values for my width and height,
Okay.
and then you have to.
Oh.
You need to figure out how to scroll this, but you just click OK on. It's kind of off the screen for me.
Oh yeah, that's ridiculous.
Does it do that on yours too?
I can't even reach the thing.
Why was
Silly PC.
Should have done that.
No.
why is your width so weird on there?
What?
Why was it so? It was like 0.00.
Oh, why did it give the funky numbers?
Yeah.
I don't know why it changed it.
But you want point.
So this is 0.1 for 10 millimeters, and then that's 0.01 for 10 millimeters and 0.1 for 100 millimeters. Okay, and why it's changing it to 0.99999, I have no idea.
And then you gotta bring this thing all the way up.
No, I don't want to do
Yeah,
that.
the window. There's a OK on the 5 right there. I push it.
Sure, whatever. Okay, so is everybody caught up? Going along? So
yours automatically put in beam under section name too.
well, no,
No?
when you here, you have to type in beam here, or well, you can type in whatever section name you want,
Yeah.
but you have to type something in.
And when you hit OK,
Then it fills it in there.
That's where we're at.
oh, okay, we can do it the second time.
Okay, so then the next thing that we have to do is the bar, well, they call it bar orientation, but it's your beam orientation. So you're telling the program that we want it to be 100 millimeters, we want it oriented with the 100 millimeters tall, and so we want it up in the x-axis, or I mean the y-axis, excuse me. So you're going to put 0 in the x and a 1 for the y to tell it that it's oriented in that direction, and 0 for the z. And I'll show you how you can check this later when we get to meshing to make sure that it's in the right orientation. Okay. So everybody got that so far?
Do you have to use the triangle brackets?
I'm not sure. That's the way it was demonstrated to me.
So
So
it says it's a vector, so
Alright.
So then you can hit OK, and again, then we're doing, you know, selections to apply it to. And we want to add all our, well, just our 3 elements, right? And then hit OK.
Oh, you did this 3 elements?
How would you want to use these here?
Well, every place that you have a connection or a change in material, or a discontinuity, right? So if we have a connection for a load, or we have a point load, or something like that, you have to create a node for it.
Yeah, I did a point 1, 2, 3. I just did the point from 4, and then I did my rod from 2 to 4 instead of 2 to 3 and 3 to 4.
Oh, okay. So apply for that. So now we're done with the properties, and we can go to loads.
See, yours went ahead and put the horizontal beam in. Mine stayed blank.
In where? Here?
Yeah.
Okay, did you enter in a name?
You had to have a property set name.
Yeah, I did. I copied what you had. And that was in,
Before I started doing any of those other input properties or any of that.
right?
Don't know. Well, I would put a name in there, see if it'll pick it up. So for our loads, let's see, I gotta create a set name for that. So we're gonna be fixed at node 1. And what does that mean? What can we resist at node 1?
It's the wall.
We can resist translations in the X, Y, and the Z, and we can also resist rotations in the X, Y, and the Z. So we'll put those in. We'll select our application region and say OK.
Did you do something with rotation? You did something with rotation on there too?
We're fixed, so we have to fix because our beam will resist rotation.
Right.
So, and let's see, our other one is at node 4. So I'm going to do, let's see, make sure that we need it. Oh, no. Fixed. Okay. Input. Select application. Yeah. Okay. So apply.
What
All right.
are you using for your loads?
I'm on just displacements at this point.
Oh.
So then I'm doing a roller at node 4. So I can wipe out my translations. And let's see, we can resist in the, yeah, because that roller's not going to resist.
You just said translation, so you want to make sure it's rotation.
Oh, yeah, sorry, I used the wrong word. That does make a difference. So we can resist, we cannot resist in the X, but we can resist in the Y and Z, and our rotations we take out. So say okay, and we're going to put it at node 4, or 0.4, okay, and apply. So we should have the two constraints. Now our force